Okay, in today's video, doing something a little bit different. I'm going to go through a homework sheet that I have given to my grade 9s, and I just want to go through how to answer each of those. So the topics on this homework sheet are going to be measurement, surface area, volume, and some trigonometry. So in the first one, we have what we call a composite shape, and we want to break that down and work out the total area. So I can put some dotted lines and change this into 3 shapes that I can calculate the areas of. So I know this shape number 1 is going to be 4 by 2 because I've got the little indication here that tells me those are all 2. I know this one in the middle is going to be 5, and I know that it's going to be the 2 plus a 4 plus a 2, so a total of 8 there. And then I know this one over here is the same as number 1, so it's another 4 times 2. So when I write my area, I can say that it's going to be the length times width plus length times width plus length times width, knowing that the length and width are different for those different rectangles, and I can even put a 1, 2, 3 up above there. So then I will work out my length times width. I've got my 4 times 2 plus my 5 times 8 plus my 4 times 2. So now I've got 8 plus 40 plus 8 is going to give me 56 meters squared. Now I could have done them individually and then added them up the end, and that's why I've given some extra space there for that question. Now over here, what we have is what we call a sector of a circle. Now our rule for that is theta over 360 pi r squared. So I need to know what angle I have of the circle here. I know this part's 90, which means this is going to be 360 take 90, which is 270 degrees. Another way I've seen students do it is say that they know this is a quarter of a circle and taking that away from the full circle. So I've got my 270 over 360 pi times, now my radius is 3 squared, so I'm going to grab my calculator. When I do the 270 over 360, it is going to give me 3/4, and I'm going to do times pi times 3 squared, which is 9, and I'm going to get 21.2, and I've got 205, so I'm going to round that to 21 on my calculator, meters squared. The next set of questions are converting units. Now I've got 4 meters squared. If I was going, and I'm wanting to change to centimeters squared, if I was just going to centimeters from meters, I would multiply by 100. But because I'm going to from meters squared to centimeters squared, I need to multiply by 100 squared. And I can type that straight into my calculator, and I get 40,000 centimeters squared. If I'm going back the other way, if I went millimeters to centimeters, then I would divide by 10. But because I've got squared to squared, that means I'm going to divide by 10 squared. Now when I divide by 10 squared, I'm going to get 5 centimeters squared there. Now the one over here, we've got meters cubed going to centimeters cubed. Same thing again. I would normally times by 100, but it's cubed. So I'm going to get my 0.005, and I'm going to times by 100, and I can put that to the power of 3 on my calculator and get 5,000 centimeters squared. Then when we're going from millimeters cubed to centimeters cubed, I would be dividing by 10 if it was just millimeters to centimeters, but I've got cubed there, so I'm dividing by 10 cubed. So I can do 4,000 divided by 10 to the power of 3, and I'm going to get 4 centimeters cubed. Then I've got some surface area questions here. Now my surface area of a cylinder, we're using a rule sheet for our exam, and on that rule sheet it has 2 pi r squared plus 2 pi rh. If we were having to break it down, we would say we had our circle top and bottom and that rectangle that wraps around, and it uses the circumference of the circle. That's where the 2 pi r comes from in that part. Now here I've got 5 meters, so I need to say that my radius is 2.5 meters, and then I can just put in the values into that rule. So I've got 2 times pi times 2.5 squared plus 2 times pi times 2.5 times 11. So I can pop that into my calculator, 2 times pi times 2.5 squared. That gives me 39.5 27. And then when I go 2 times pi times 2.5 times 11, I get 172.78, and I'll round that to 79. Then I'm going to add those two numbers together, and I get 212.05, which I'll round to 0.06. Then I need to put my units, which are going to be meters squared. The next one I have is a box, and I know when I do my box that I've got 2 lots of length times width plus 2 lots of width times height plus 2 lots of length times height. Now, if you weren't sure, you could do your net and break that up into the different shapes. So we've got length and width are our top and bottom, width and height are our sides, and length and height are our front and back. Putting that into the rule, I've got 2 times 10 times 2 plus 2 times 2 times 4 plus 2 times 10 times 4. So I've got 40 plus 16, and then I've got 80 there. And when I add that up, I get my 136 meters squared. For the next one, we've got volume. So we need a different rule for volume. It's our area of base times height, but we also know a special rule for cylinder, which is pi r squared times height. Now in this case, we've got pi times 3 squared, because our radius is 3, times 10. So we can put that straight into our calculator. Pi times 3 squared times 10. And we get 282.74, and that will be meters cubed. The next one we have is a nice easy box. So our volume is length times width times height, because we've got area of base times height, and our base is length times width. So we've got 2 times 1 times 10. So we will get 20 meters cubed. Now onto the second side, we have our Pythagoras to start with, and then we've got some trigonometry. So for our Pythagoras, we always want to label our triangle first with our ABC. We know it's Pythagoras because there's no angle involved here, none unknown or known. So we've got our C goes on the X, and then we can put A or B on either of these two. It doesn't matter which one we do. Then we can write our C squared equals A squared plus B squared, and then we have X squared is going to equal 4 squared plus 8 squared. When I do 4 squared plus 8 squared on my calculator, I get 80. So my X squared is equal to 80. So my X is going to equal the square root of 80. And I will get 8.94, and that will be meters. For our next one, we've got our C is on the 11. We can put our A and B on the 5 and the X, doesn't matter which is which. We write our rule, C squared equals A squared plus B squared. Then we're going to put our 11 squared there. We've got our 5 squared plus X squared there. So to get the X squared on its own, we're going to do 11 squared take 5 squared. So I'll get my calculator and do 11 squared take 5 squared, and I get 96. And then to get the X, I'm going to do the square root of 96. So I'm going to get my X is 9.797, so I'm going to round that to 9.8 meters. Okay, having a look at my trigonometry. I've got labeling each time. So I need to put my A, O, and H there. That then tells me which ratio it's going to be. So I'm going to write that it's cos theta equals A over H. So cos of 45 is going to equal X over 11. So 11 cos 45 is equal to X. I'll grab my calculator and I will do 11 cos 45, and I get my X is 7.78, and that will be meters. Next one, labeling my triangle again, A, O, and H. And so then that means I've got sine theta equals opposite over hypotenuse. Sine 70 is going to equal X over 20. So the 20 is on the bottom. I'm going to multiply, and get 20 sine 70 is equal to x. So I've got 20 sine 70 on my calculator, and I get 18.793. So I'm going to round that to 18.8 centimetres this time. We've got centimetres on our triangle. Now over here, I'm going to label my triangle again, AOH. Circle what I've got, and I've got tan this time. So tan theta equals opposite over adjacent. Then I'm going to put in my tan of 50 is equal to x over, opposite over adjacent, so that's 14 over x. Now my x is on the bottom, so that means I'm going to make these two switch places. So I'll get x is equal to 14 on tan 50. Then I'll grab my calculator and do 14 divided by tan 50. And I get 11.75, and that will be millimetres. Okay, so this one we're going to label our triangle A, O and H. So then I've got O and H there. That means I'm going to use the sine ratio. So I've got sine theta equals opposite over hypotenuse. So sine of 50 is equal to 10 over x. Same as the one on the line before, where we have the x on the bottom, so we make them switch sides. X is equal to 10 on sine 50. So we will do 10 divided by sine 50, and we get 13.05, and that is metres. Here we've got one that's drawn a little bit differently, but we can still go with it. We've got our H here, our A is near our angle, and our opposite over here. So we've got opposite and adjacent, and we're finding the angle. So we write tan theta equals opposite over adjacent. We fill in what we know. Tan theta is equal to 4 over 5. Now here's where we do something a little bit different to what we've done in the other ones, is that we do tan to the negative 1 of 4 over 5. So when we're using that on our calculator, we're doing second tan, and we're typing in that fraction, 4 over 5, and so we get 38.66. And that will be degrees, because we've got the size of the angle in this one. Now our lucky last one, we're labelling our triangle AOH. We've got A and H here, so we write cos theta equals adjacent over hypotenuse. Cos theta equals 7 over 11. So my theta is going to be cos to the negative 1, 7 over 11. I will grab my calculator, second cos, 7 divided by 11. And I get 50.48 degrees. Okay, hopefully some of those questions were helpful, and this explanation helped you work through some of those problems.